Hey guys, welcome back to Learn in DSA. So today we are going to solve LeetCode daily of 19th June, the problem number 2294. So here what we are provided partition array such that maximum difference is k. So basically it is almost similar to the LeetCode daily of 18th June yeah, in 18th June problem it was written that we have to divide it into triplets, the subsequence, but here the difference is we have to partition array such that the maximum difference is k. So here that triplet condition is not there, only we have to divide it into the minimum number of sub arrays. So basically what we are provided, you are given an integer array nums and an integer k. You may partition nums into one or more subsequence. So we can partition into multiple subsequences such that each element in nums appear in exactly one of the subsequences. So we cannot repeat a certain number into multiple subsequences. One number can appear only once. Return the minimum number of subsequence needed such that the difference between the minimum and the maximum values in each subsequence is at most k. So the difference between the maximum and the minimum element in each subsequence should be at most k. So a subsequence is a sequence that can be derived from another sequence by deleting some or no elements without changing the order of the remaining elements. Okay, so let's discuss one of its problems. So if we let's use the note. Okay, so for this if we use note, nums equals 3, 6, 1, 2, 5 and k is 2. So basically if we are provided 3, 6, 1, 2, 5, so this is nums. Okay, so if we want to divide it into subsequences having the maximum and the minimum difference as 2, so what we can do is how we can approach this. So if we sort the array like the previous problem, we can sort the array into an increasing order. So if we sort it, then it will be like 1, 2, 3, 5 and 6. So after sorting we can see that we can partition the nums into two subsequences, 3, 1, 2, here it is provided. So let's solve this on our own. So if we try to divide this into subsequences, then the first sequence can contain 1, 2, because 2 minus 1 is 1, the max element is 2 there and the min is 1. So another element can come 3, because 3 minus 1 is 2, which is lesser than or equals to k, and that is 2. So 2 is equals to 2. So basically we can take this in one subsequence. Okay, and to get the another subsequence we can take the remaining elements. Okay, so 6 minus 5 is basically 1, which is lesser than 2, that is lesser than k, so we can take this. So if what we can return in the output is the number of subsequences are 2, so output will be 2. Okay, so if we move on to the another example, nums equals 1, 2, 3. So it is provided k equals 1. So what we can do is, if nums is 1, 2, 3, okay, if nums is 1, 2, 3 and we need not to sort this because it is already sorted. So if we divide, and here k is provided as 1, so 2 minus 1 is 1, 3 minus 1 is 2. So 1, 2, 3 all cannot come in one sequence. So what we can do, 1, 2 can come in one sequence, one subsequence, and 3 can be in another. Okay, so basically if we subtract 3 from 3, then it is 0. So we can keep 3 in another subsequence. Okay, so moving on to example 3, here we are provided nums equals 2, 2, 4, 5. Okay, so basically here k is provided as 0. The difference between the max and min element should be lesser than equals to 0. So if the elements are same only, then we can keep them in a subsequence, else we have to keep them in another subsequence. So basically what can we do, 2 and 2 are same elements, so we can keep them in one subsequence, 4 we can keep in another, and then 5. So basically what we will be getting in output is the number of subsequence. So basically output will be how many subsequence we have here? 3. So basically it will be 3. Okay, so let's move on to the coding part of this. So the constants also here are provided, like nums dot length is less than or equal to 10 to the power 5. So size can be less than or equal to 10 to the power 5, and k is also less than or equal to 10 to the power 5, and num size is also less than equal to 10 to the power 5. No negative elements are present here, only positive elements are present. So we need to take care of that. So basically what will be our greedy approach to solve this? So if we look into the greedy approach, then initially what we are doing, we are sorting the total array whatever is provided. First we need to sort that, and then what we need to do is we need to greedily group numbers, because if we start the new subsequences with the first number, then we keep on adding elements to the subsequence as long as the difference between the current element and the start is less than or equal to k. So basically we are first keeping the first element in the subsequence and then increasing the I, that is increasing the index of the subsequence, like moving on to the next element, and keep on adding those elements to the subsequence whose difference with the current element and the start, like the difference between the current element at whatever index we are and the start element is less than or equal to k, then we will be keeping those elements. At the moment when we get the difference between them as more than k, so we start a new subsequence, and what we need to print in the output, we need to print the number of subsequences, number of such kind of subsequences. So what can we do at this time? We need to sort our array whatever is provided. So here nums is the array provided, vector int nums. Here we are using C++ language. You can use the same logic into your desired coding language. Okay, so basically to sort, we are using the sort function provided in the library already in C++. This generally uses the quick sort at the back and it takes a time complexity of big O of n log n. Okay, so num dot n, we need to sort that, because so we need to keep a count of the number of subsequences. So we will be keeping a count variable, and int I equals 0, because our index starts from the first element only. Okay, so I equals 0, and what will be the size of the nums vector? So n equals nums dot size. Okay, so what we need to do, we need to calculate if the max and the start is at difference is less than or equals to k. So for that we need a loop. So here we can use a while loop. It will be going from which will be starting from I equals 0, and it will go till I is less than n. So what we will be doing while I is less than n. Okay, so we need to store the first element, like we need to initiate the start with the first element only, and here we have already provided I as 0. So what we can do is we can keep start as nums I, because I is already initiated with 0. Okay, and we need to increase the count if the subsequence is increasing. Okay, so for to check that, what we will be doing, we will be running a while loop again, where I is less than n, and the difference between the current element and the start element is less than or equals to k. So while I is less than n, and nums I is the current element minus start is the first element, if that difference is less than equals to k. Okay, so what we will be doing, we will be increasing the index. Okay, so basically those elements whose current and the start is less than equals to k, so it satisfies the condition to remain in that subsequence. Okay, so we will be incrementing the I value, like we will be incrementing the index, and what we need to return at the output is the number of such kind of subsequences. Okay, so when this loop fails, then we ought to know that the difference between the current and the start is greater than k. Okay, so again the count variable will be incremented. So again, like it will go on in this loop and in this loop, and then again the count variable will be incremented by 1 by 1. So in that way we will be getting the output, and we can simply return count as the output. Okay, so let's try to run this. Okay, so let's see if it works. Okay, here we have done a simple mistake. This num is it's nums, not num. Okay, so let's see if it works. Accepted. Okay, let's submit this to check if it is working fine. Okay, so it has worked fine, and let's look into the time and space complexity as well of this algorithm. So basically, if we look into this algorithm, then the sort function is taking a time complexity of big O of n log n, okay, for the sorting, okay. And the space complexity is because we are doing an in place sort, and the extra variables are also constant, that is the count, int count is an extra variable and that is a constant. So the space complexity will be big O of 1, okay. So space complexity will be big O of 1. So I hope it clarified the today's daily LeetCode, and thank you guys for watching this.